Hello everyone, welcome back to my YouTube channel Physics Unification. If you have not seen it, I already attached those links in a description box. Please go through it. Today we can continue with the next topics of the chapter, ray optics and optical instrument. First of all, what do you mean by refraction? That is the bending of light when it passes from one medium to the another medium. Here we can derive the derivation based on the refraction of light through a prism. That one is the derivation of expression for refractive index of the material of the prism. Let us consider a prism ABC, triangular shape prism ABC. When ray of light PQ, which is incident on the first face of the prism AB. Here I be the angle of incidence. R1 be the angle of refraction for the first phase AB. R2 be the angle of incidence for the phase AC, and E be the angle of refraction or angle of emergence. The angle between emergent ray RS and the direction of the incident ray PQ is called the angle of deviation delta. This delta is the angle between emergent ray RS and the incident ray PQ. In the quadrilateral ARNQ, Q and R are right angle triangled. Angle A plus angle RNQ, that is sum of the other angles of the quadrilaterals is equals to 180 degree. Angle A plus RNQ is equals to 180 degree. From the triangle RNQ, sum of all the angles inside the triangle must be equal to 180 degree. That is R1 plus R2 plus RNQ is equals to 180 degree. That is equation 2. Comparing equation 1 and 2, what we can write? RNQ is same. Here on right hand side 180 degree same here. So therefore angle A, which is equals to R1 plus R2. Equation 3. Angle of emergence can be taken it as E is equals to I2. Therefore, total deviation delta can be written it as angle of incidence minus angle of refraction, I1 minus R1 plus angle of emergence minus angle of incidence, I2 minus R2. I1 plus I2 minus R1 plus into minus R2. I1 plus I2 minus R1 plus R2. That is, just take minus outside the bracket. Then total deviation delta can be written it as I1 plus I2 minus of A. This is by equation 1. Delta is equals to I1 plus I2 minus A. Here A equal to R1 plus R2, that is by equation 3. Equation 4, which shows angle of deviation which depends on angle of incidence I1 and angle of emergence I2. At the minimum deviation, delta can be written it as minimum deviation dm. Angle of incidence, it must be equal to angle of emergence I2. I1 equal to I2. R1 equal to R2. By equation 3, that is A equal to R1 plus R2, what we can write? R1 plus R1. In place of R2, what we can substitute? Value of R1. Then it becomes 2R1. R1 is equals to A, or R1 equal to A divided by 2. Now by equation 4, that is delta is equals to I1 plus I2 minus A, that can be written it as, in place of delta, what we can write? dm, minimum deviation, dm is equals to I1 plus I1, that is 2I1 minus A. dm, here it is minus sign, when it is comes to left hand side it becomes plus A divided by 2 is equals to I1, which gives angle of incidence I1 is equals to dm plus A divided by 2. Graphically, angle of deviation taken along y-axis and angle of incidence taken along x-axis. Then at minimum deviation, angle of incident, it must be equal to angle of emergence, that is I equal to E. That is I1 equal to I2. And here from Snell's law, n21 can be written it as n2 by n1, which is equals to sin I1 by sin R1. n1 sin I1 is equals to n2 sin R1. n21 is equals to sin I1 value is equals to dm plus A divided by 2, all divided by sin R1 is A divided by 2. Therefore, n21 can be written it as sin dm plus A divided by 2, all divided by sin A divided by 2. Here A is the refracting angle of the prism and dm is the angle of minimum deviation. Up to here, this derivation is very important for 5 marks and also for problematic part. Dispersion of light by a prism. The phenomena of splitting of light into its component colors, means white light after dispersion, which splits up into 7 colors, that is Vibgyor. The pattern of color components of light produced during dispersion is called it as spectrum of light. Now, how dispersion takes place? Usually dispersion takes place because the refractive index of medium is different for different wavelengths. When white light undergoes dispersion through a prism, the color obtained in the sequence of violet, indigo, blue, green, yellow, orange and red. Here, red light bends the least while the violet light bends the most. And in the similar way, red light travels faster and violet light is slowest in the glass prism. Here, red light is least scattered and which contains more wavelength, lambda. Here, violet is most scattered light ray and shorter wavelength. Next topic is Rayleigh scattering. Here, intensity of scattered light is inversely proportional to the fourth power of the wavelength. Example, we can see scattering of light by air in the environment. Now, why sky appears blue in color? This is because of Rayleigh scattering. According to Rayleigh scattering, intensity of scattered light is inversely proportional to the fourth power of the wavelength. Hence, the light of shorter wavelengths, violet, indigo and blue, are scattered much more than the light of longer wavelength, orange and red color. In fact, violet indigo scattered more than blue color, having a shorter wavelength. But our eyes are more sensitive to blue color. Hence, we see the sky as blue in color. Next concept, it is reddish appearance of sun at sunrise and sunset. This is also because of Rayleigh scattering. At sunrise and sunset time, sun rays have to pass through a longer distance in the atmosphere. According to Rayleigh scattering, intensity of light is inversely proportional to the fourth power of the wavelength. Most of the blue color and other shorter wavelengths of sunlight are removed by scattering. Least scattered red and orange color reaches our eyes. Therefore, sun looks reddish in color. Next concept is optical instruments. Then, before going to that concept, we have to know the concept of accommodation. Accommodation means ability of the eye to change the focal length by the action of ciliary muscles so that the image is always formed on the retina. Ability of the eye to change the focal length by the action of the ciliary muscles so that the image is always formed on the retina. Let us see the one more problem based on the refraction of light through a prism. The angle of minimum deviation produced by a 60-degree prism is 40 degree. That is, given quantity, angle of deviation dm is equals to 40 degree and refracting angle A is equals to 60 degree. Calculate the refractive index of the material of the prism. N21 we have to find out. We know N21 is equals to sine dm plus A divided by 2 whole divided by sine A divided by 2 formula. Substitute value of dm and A in the equation, then we will get N21 is equals to sine 40 degree plus 60 degree divided by 2 whole divided by sine 60 divided by 2. N21 means refractive index for glass divided by refractive index for air is equals to sine 40 plus 60, 100 divided by 2, that is sine 50 degree divided by sine 60 divided by 2 is 30 degree. Ng is equals to N1, Na refractive index for air is 1 into sine 50 degree divided by sine 30 degree. Value of Ng is equals to sine 50 degree is 0.766 divided by sine 30 degree is 1 divided by 2, which is equals to 0.766 into 2. Therefore, Ng is equals to 1.532. That is the refractive index of the material of the prism, which completes the fifth part of the topic ray optics and optical instruments. In the next video, we can go through the topics of myopia, hypermetropia, astigmatism, and optical instruments topic, that is microscope, compound microscope, telescope, and reflecting telescope. If you have any doubts regarding these topics, please drop a comment in the comment box. Stay tuned, like, share, and subscribe my YouTube channel Physics Unification. Thank you.